My name is Ian Simpson. I'm a senior staff software engineer at Ripple, a company you may have heard of. And I'm going to start off this presentation with some bad news, audience participation. All right, quick show of hands. Who's done issue currencies before or played around with issue currencies? All right, a couple people. Who has used the Trustlines feature on the XRP Ledger? More people, okay. Who's familiar with but therefore storytelling style? I got you there. It's going to come into play. That's why I asked. And lastly, who looked at this and went, it's 5 o'clock. This presentation says easy in the title. I just want to coast. It's okay. All right, that's good. That's good. Let's get to the table of contents. So I'm going to go through a few things here. First, what is an issue currency? Not everyone raised their hand. It's good we're covering this. Second, our story of how we're using issue currencies on the XRPL. Spoiler alert, stablecoins. What we had to do to solve balance tracking with issued currencies. It's a bigger problem than you might think. Usually you think it's blockchain, we have money, we have balances. Not so fast when it comes to using Trustlines. Going to talk about how we plan to evolve what we built and our plans to share it with you. So let's get started. Issue currencies for the uninitiated. This diagram is straight from the wonderful XRPL help docs. And it describes the relationships that you have between accounts when you're handling issue currencies. So, issue currencies are often referred to as fungible tokens, a terminology that many of you have probably heard. A common use case for these is fiat-backed stablecoins. It uses the Trustlines feature of the XRP Ledger. An account must have a trust line to the issuer in order to be a holder of tokens. And tokens are issued via payments from the issuer account to another account, and they're redeemed or burned by making a payment from one of those accounts back to the issuer. All of these lines that you see represent debt relationships. So when you issue a token from an issuer account, you're creating a debt relationship. It's not just you're handing over money to someone, they can claim it back from you, which is how it ends up working with stablecoins as well. If you get USD over a trust line on the ledger, we end up with USD in a bank account that you presumably sent to us in order to get those coins, which also means that if you send it to someone else, they could go back to us, get that fiat money back if they wanted to off-ramp. Let's talk about our issue currency story working on the stablecoin project. Needed to be able to make issue currency payments and track changes to issued currency balances. Seems like a common sense thing to do, right? If you're gonna handle issue currencies, you need to move money and you need to see what the totals are of that money that you moved. Therefore, we created a system to pull the XRPL for finality and retrieve balances periodically. But this created some problems for us. Polling for finality is inefficient and a poor user experience. If you're doing this for every transaction that you submit, let's say that you're polling every 4 seconds and a transaction settles in 4 seconds, you might catch it right when it finalizes, or you might catch it 4 seconds after it finalizes, and that's not a good user experience. You're finding that finalization way later than it happened. Polling for balances is slow and expensive. When you're trying to get the balances for issue currencies, you have to load all of the trust lines on the issuer account. If you're trying to find the total amount issued along with all the balances for the accounts, you have to sum all those up. The sum of all the balances of all the trust lines represents the total amount issued. It's not stored as just some scalar on the issuer account. It's a sum of every debt that the issuer holds. Both of these can get you rate limited, which is a worse problem. Because if you get rate limited, you've got nothing. Can't submit, can't poll, can't get balances, you're dead. Therefore, we made a choice to use WebSockets instead to get a stream of data so that we get changes in real time. But WebSockets aren't super reliable. I don't know anyone else experienced this, but we certainly have. Connections can be lost, right? It's a persistent connection over the network. You're at the behest of the internet. That connection can go away very, very easily. Maintaining more than one connection means you're deduping data. So both connections are going to get the same stream of data coming back if you're subscribing to closed ledger events, which means you don't want to necessarily process those multiple times. So you're going to want to have something that's going to condense those down into one single source of truth for other people to consume. Missed data must be accounted for later. So let's say you're getting a stream of ledgers, you get 1 through 10, connection goes down, then you start getting 15, you missed 11, 12, 13, 14. If you're trying to give someone a complete stream of data, you need to go back, figure out those things that you missed, make it up. Therefore, we had an application that used cluster coordination to make sure that we have one open WebSocket so that we are not constantly deduping data against something like a relational database. The application is also able to find gaps in that data and fill in what we missed. So both of those problems that we talked about, we could solve. We can find 11, 12, 13, 14 when it gets missed because the connection went down, and we can make sure that our cluster only maintains one active connection to the ledger that we want to talk to. But clients don't want to consume all the data coming in on the ledger, right? Usually you're concerned about a few accounts that you have funds in, or maybe you're custodying keys for other customers and you're moving money on their behalf. They also want to receive data about the ledger in a durable and fault-tolerant way. If you're just making an HTTP call, then there's a chance that could fail due to a number of reasons, and if you miss that call for some reason, it's hard to get that call to come back to you again unless you negotiate some kind of retry policy ahead of time. Therefore, we added a subscription model to our application. So our clients can just subscribe to an account that they want to get events on. And we integrated that with Amazon SNS and SQS so that you have durable eventing coming back to the client. So something goes down, they miss a message, it can get redriven a few times. If that redrive policy is exceeded, it ends up on a DLQ, it could be redriven later, but the point is there are already ways of handling this with those technologies that we could leverage to our advantage. But this didn't give us the ability to track the balances that we were talking about. It solved finality. We could get finality very, very close to when finality actually happens, which is a much better user experience, but we don't handle balances yet. Therefore, let's talk about how we track issue currency balances. We enhanced our subscription model that I talked to you about by adding qualitative filtering. So our subscriptions were detecting all the transactions on the accounts that were entered. We just needed to have a way of saying, hey, this one's an issuer account. I want you to pay attention to the issued currency payments happening at this issuer account with a specific currency code, and then I want you to aggregate all of that data. So this qualitative filtering turns into quantitative data. We have a new subscription type in our application where clients can watch for activity on an issuer account, and we can watch for payments to come through and then build up balances for the issuer account as well as all of the other accounts that have Trustlines to that account that you care about. So you could add subscriptions for those, and it'll tell you the balances between the issuer and all the accounts that you're watching. But these payments are only deltas. Unless you establish a baseline, you are going to have inaccurate data because you don't know when the client created the subscription. If they did it when there's already balances between these accounts, you already have potentially some activity that's representing a transfer of funds that you need to account for before you apply payments as deltas. Therefore, We added an eventing system that retrieves the Trustline balances when the subscription is created, and it periodically will pull them down again just to make sure that everything is accurate on our balance tracking. And then we apply payments to those balances as long as they have a later ledger index. This is a condensed version of what our schema looks like that I'm going to walk you through. So on the top left here, we have the balances that we fetch from the ledger. On the top record there, you might notice the address and the issuer address are the same. In our schema, this is how we track whether or not this is the total amount issued by the issuer address. For the other two, we know that RO2 and RO3 have trust lines to issuer RO1. RO2 has a balance of 100 at ledger index 100. RO3 has a balance of 50 at ledger index 100. This 1,000 up at the top is the total amount issued. So since it's the issuer address, that means that that's the total amount in circulation. On the bottom here, we have some payments that we got in. So we could see a payment from R2 to R3. For 20 units, we can see a payment from R3 back to R2 for 30. And then we have one at the bottom, R2 to R3 again for 40. The numbers that we calculate when we're sending data back for our computed balances are, we have still the 1,000 that's in circulation. Then we can see, because we netted 10 between these, right? We have 30 one way, 20 the other. These balances over here shifted by 10 each, right? We have 110 and 40 instead of 100 and 50. This one's not included because that one happened at ledger index 99. Our balances are at ledger index 100. These two payments are at ledger index 101. So now we know what our balances are at ledger index 101. We exclude 99. We don't want to apply that delta since it would have already been accounted for in these. But this doesn't help our clients understand balance changes because sending raw deltas causes an ordering burden on them. If every time you see that table in the top right change, you send it on over, now the client has to do some work of making sure that it arrives in sequence because they don't want to apply things in the wrong order, get stale changes. Therefore, we just send them a very generic message saying, hey, the balances of this issuer account changed. We create a RESTful web service that they can call. They could get a cache copy of the balances, and this gives them an idempotent way to get balance data whenever they need it. And they don't have to worry about how many times they receive a message. If they handle it 10 times, that's the same as handling it once. So this makes issued currencies easy for the clients that we have right now. The clients only need to create a subscription on an issuer account and the other accounts that have trust lines to that issuer account that they want to watch for activity on. Clients receive events when finalization is detected. They don't have to wait an inordinate amount of time to pull. Clients receive events when balances change. Clients can retrieve a cache version of the balances, so they don't have to go through the process of loading all the trust lines from the ledger. It's very, very fast. We're offloading that load for them. No more polling, which means we don't have to worry about getting rate limited, and we don't have to, again, paginate through all these trust lines at the issuer. So now that you have an idea of where we're at, let's talk about how we want to evolve it. Two major changes we're considering. One, do we even want WebSockets? Now that may seem antithetical to what I started out by saying, where I said polling is evil, let's use WebSockets. But I promise there's a method to this madness. WebSockets are a bit fragile and they require cluster coordination. So one thing we are considering is if we switch to serverless and we have something that's effectively a serverless heartbeat that does do a poll, but because it's only looking for closed ledgers, we can poll very close to the rate at which ledgers are closing, get accurate data without there being too much slip between when finalization happens and when we detect it, and then send that over to the cluster. And the upshot of this is if we do this correctly, it eliminates the need for cluster configuration because you no longer have this burden on the cluster of juggling this one WebSocket connection, or conversely switching to opening up multiple WebSocket connections and then dealing with deduping data. We could also have that serverless function account for those gaps as well. basically the serverless function would send messages to our cluster saying, go look at this closed ledger, go look at this closed ledger as it's coming in. So if it's filling a gap versus getting live data, the cluster doesn't know the difference and it doesn't really care, but it is way more reliable. The other question that we're asking ourselves is, do we need to be relational? And some of that is predicated on whether or not we switch away from this first one here. But most of what we use an RDBMS for goes away when we switch to serverless detection of closed ledgers. Our index and access patterns on our database schema are actually pretty simple. They only go off of 1 or 2 keys. Generally speaking, NoSQL stores can handle 1 or 2 keys pretty easily. If we do this, we're looking at DynamoDB right now. We're already in AWS, and DynamoDB does have a lot of nice capabilities that we could take advantage of. So that may be a change we end up making to the system. The last thing that we're thinking about potentially changing is adding time series data. So we already see all of this data, right? We're getting these diffs in. We try to not send them to the client directly because that could burden the client who they just want to show what the latest balances are. They don't want to have to worry about the order of events that are happening. But because we already see this data, we can produce this series of how the balance has changed over time. We want to figure out what database, or we need to figure out what database we want to use. Generally, if you're dealing with time series data, there are databases that specialize in this kind of data storage. They're optimized for it. It probably makes sense to revisit publishing these deltas that we were talking about avoiding before, because we probably want to put this in another service. If we were to put this in the application that we already built, it would probably be a little bit too much responsibility for one thing, and it would slow down some of the other behavior potentially. And seeing this data, seeing issued currency balances change over time, having that nice graph of money moving is something we've had customers ask for. So there's clear business precedent to try to introduce this, and I know it's not just for us. I know there are other customers out there that want to have this kind of data, and it's something that's kind of hard to do with the XRP Ledger right now. The good news is we'd like to share our toys with you. Believe it or not, we need to put together an open source policy. Now this might be confusing because Ripple is well known for having open source software, but when it's an internally developed project, it's not quite as easy. So if we're starting a project that's going to go open source, we have a way of guiding towards that. But when we start something internally and it solves a problem really well, and then we say, hey, we want to give this away, we actually don't have a good off-ramp for it. So we're working on that right now to put together all of the parties that we need to look at a project after it's had a considerable amount of development work, because we obviously don't want to give away trade secrets or intellectual property or anything else. So that's in flight right now. Once that is in place, we plan on using it on the application that I just talked to you about today. And the application's pretty simple. It's a Java Spring Boot application. It plugs into AWS Cloud right now through all of Spring's AWS integration. So when we do open source this, if this is something you're interested in and you want to run yourselves, it's not going to be too big of a lift. It's just a very common, relatively vanilla technology stack on purpose. And with that, everybody loves a question slide, right? So if you have questions, feel free to request the mic, but if you don't, or if you do, I'm not going to say I'm not going to thank you if you have questions. That'd be rude of me. Whether or not you have questions, thank you for coming to my talk. I really enjoyed presenting to you today. We have 5 minutes.
Any questions? Oh, there's one in the back.
So did I understand it right that you need an AWS account and to use this software then?
Kind of, sort of. So we are currently deployed to AWS. We still have some linkage in place to use to potentially use Kafka instead of AWS. That will likely leave in place. We don't use it right now just because it's much cheaper. We don't really need Kafka's ordering guarantees. We mostly had chosen it at one point because it's a ubiquitous thing. Like any cloud provider can run Kafka, anyone can use Kafka. So there will be alternatives there for the messaging provider. As for the database, right now we're just using Postgres, which you can obviously run Postgres for free. For local development, if you were to pull it down and start playing around with it, and AWS was a concern or you didn't have an account, there's a container called Local Stack that simulates all of the AWS services. So if you run a local stack container, you're in a Postgres container, you could run this locally and start to develop with it. So there's nothing that's going to really force it into AWS right now, I would say, between the Kafka and Postgres support. And even if we were to move away from relational and go towards Dynamo, I think we'd be very careful, especially going down the open source track, about not picking something that forces you into vendor lock-in, but having some other alternative that allows you to use a data store that will work on any cloud provider that you might select.
How you doing?
Hi. Good. How are you doing?
Good.
Good.
And it was a good talk.
Thank you.
Regarding, you said Postgres, it's not for the time series, right? Time series is more like a dynamo.
Yeah. Well, so for time series, there is a spin-off. Spin-off's not the right word. There's another database called CockroachDB that it's underpinning. It sounds like you know about it. Yeah. So for those who don't, CockroachDB is kind of built on top of Postgres. It's for time series data, but that's one of the ones that we've floated for using it.
And that would grow pretty large for that amount of data. How do you run nodes like that for? You're not Ripple.
For time series data?
Yeah.
I don't know. I don't have the answer to that one. Time series data is just a beast to deal with. Like, it has huge storage implications, like usually the reports that you run are really, really expensive. The only time I know I've dealt with time series data in my career, it's been with these big multi-million-dollar data warehousing solutions. So I think the first goal is like expose the time series data and as just part of the service, and then the second part of that is figure out a way to store it. But like it might be like BYO storage for that, because like you said, like Ripple can bear the brunt of that, and they have substantiated customer use cases where they could say, well, it's costing us this much to keep this data, but we're getting this much in business from having it. But that's a difficult thing for some companies to manage.
And the actual question is about MPCs and do they change the design of how data is stored and Trustlines work? MPC, multi-purpose coins or multi-purpose tokens.
So are you talking about the feature that was talked about earlier during? So that was the first time I've heard of that. So I probably can't speak very intelligently about it. I don't know if it's actually going to use Trustlines the same way. I'm guessing it would be a different a different way of storing those values on the ledger, and it wouldn't piggyback on it, but I'm not 100% sure yet. So I'm sorry I can't give you a better answer than that.
Okay, here.
All right.
My question would be, what are your latency goals with this solution? What latency have you measured so far?
So we're trying to be within. We don't have very well defined goals right now, to be perfectly blunt. We're trying to stay within like 2 seconds or so of finality being detected. Some of that this is where the question around swapping out the WebSockets comes in, because one of the problems that can happen with WebSockets, particularly on mainnet, is the host that you're connected to could start to run behind, and then you're no longer actually getting your finality alerts like in lockstep with when they're happening. So that's what's causing us to reevaluate that right now, so that we do stay close to what that actual range is. But that's what we try to target. Some of that is based on just kind of fuzzy math of this seems like about as fast as it flows through all of our machinery. The other one is we try to target that number because if you even though we don't have a retail use case right now, if you look at retail trends on other websites, there's all sorts of data that shows people's patience falls off a cliff after about 2 to 3 seconds. So you do want to try to keep those interactions as tight as possible to keep people from disengaging with the platform that you're using.